Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder if your phone, or more specifically your chats, can tell us something about your mental health? Well, this new study dives right into that. Imagine if the words you type in a mental health app could actually give us clues about how you are feeling, especially when it comes to depression. That is exactly what researchers set out to explore in this fascinating investigation. The big question here is, can the language we use in digital mental health apps give us insight into our struggle with depression, without us having to fill out long, sometimes tedious questionnaires? Think about it. Many of us use apps for support, and these apps collect a lot of text data. This research team wanted to see if they could use that text data to understand people's depression symptoms. So why is this important? Well, mental health issues are a huge global problem, and sadly, not everyone who needs help can get it. Digital mental health apps can be a game changer because they're accessible and private. But to make these apps truly effective, especially the ones with chatbots, we need ways to track how people are doing, beyond just asking them to fill out surveys week after week. Those surveys can be a burden, and sometimes users just skip them, leaving a gap in our understanding. The researchers thought that the natural language people use when interacting with these apps could be a goldmine of information. When you're talking to a chatbot or using an exercise within the app, you are expressing yourself, and our words, as scientists well know, can reveal a lot about our inner world. There is a growing body of research looking at how language can signal depression. Some studies use specific word lists like the LIWC system to count certain types of words. For example, they might look for more words about oneself, or words related to sadness, or even all or nothing thinking. These word-based methods have found some consistent links to depression. But the scientists in this study wanted to go further. They knew that just counting words might miss the nuances and context. So they also turned to more advanced techniques using something called language model text embeddings. Think of these embeddings as sophisticated ways to capture the meaning and context of entire sentences or paragraphs, not just individual words. These methods are like giving the computer a much richer understanding of what you are actually saying. They used a specific model called Gillan 3 8b embedding to create these representations of the language. Now, a lot of past research has looked at social media posts to find these language clues. But social media has its own issues like privacy and who is actually posting. This study, however, used data from a real-world digital mental health app called Wobot, which offers cognitive behavioral therapy through a chatbot. This is important because the language here is more directly related to mental health support. So, they took data from a huge number of Wobot users. They focused on the language users typed during their first week on the app. They then built computer models specifically using a technique called XGBoost, which is really good at making predictions. They trained these models to predict depression scores using two main types of language information. First, the word-based LIWC features, and second, the more advanced text embeddings. They trained these models on data from over 26,000 users who also completed a symptom questionnaire. When they used the LIWC system, which counts specific word categories, the model could predict depression scores, but only modestly. It explained about 9% of the variation in depression scores. The most important words or features they found included things like mental health, all or nothing thinking, work, and sadness. This shows that even simple word counting can pick up on some signals. But here is where it got more exciting. When they used the text embeddings from the Gillan 3 8b embedding model, their prediction model performed significantly better. The ability to predict depression scores improved. It explained about 17% of the variation in depression scores. That is almost double the success rate of the LIWC model. This improved model using embeddings also showed good generalizability. That means it worked well not just on the data it was trained on, but also on new data from later weeks of app use by different users. They found a meaningful correlation between the depression scores predicted by the language and the actual scores from questionnaires. Now, here is a really cool part of the study. They were able to use their language model to estimate depression symptoms for users who never filled out any symptom questionnaires. We're talking about hundreds of thousands of users here. And what they found was pretty striking, these language-based estimates for group. Level depression showed patterns that were consistent with the questionnaire data from other users. This is huge because it means we can potentially track mental health trends for a much larger population, even those who don't engage with traditional surveys. So, what does all this mean? The study strongly suggests that the language we use in these digital mental health apps is a valuable source of information about our depressive symptoms. The more advanced language models, the embeddings, were particularly good at capturing these signals. Now, it is important to be realistic. The study points out that while the models are promising, the performance was modest. They could explain about 17% of the variation in depression scores. This means that depression is complex, and not everything is captured in the text alone. These models are not yet precise enough for diagnosing or closely monitoring individuals in a clinical setting. The researchers emphasize that these findings are best suited for understanding group-level trends. Interestingly, they noticed the difference when comparing the text only estimates to questionnaire scores. The text-based estimates tended to be a bit higher and more stable over time compared to questionnaire scores, which often showed a decrease as users progressed. They think this might be partly because the models tend to lean towards the average, and also because the training data might have had a slightly different distribution of scores compared to the later usage data. They also looked at predicting individual depression symptoms. Again, the embeddings models did better. Symptoms like depression or sadness and negative or unwanted thoughts were easier to predict from language. However, symptoms related to sleep or concentration were harder to pick up. This makes sense, as some feelings are more directly expressed in words than others. The practical implications for digital mental health apps are significant. Instead of relying solely on questionnaires that users might skip, apps can use the language data they already collect. This is a low-burden, cost-effective way to get a pulse on how users are generally doing. This can help app developers understand if their content is working, or if certain features are more helpful for specific groups. What's next? The researchers suggest several exciting avenues. They want to improve model performance perhaps by training language models specifically on mental health-related text. They also want to look beyond just a general depression score to more specific symptom tracking or even predicting other mental health conditions like anxiety. Imagine if your app could not only track your mood but also offer content specifically tailored to your needs based on your language. So, to wrap it up, this study makes a really strong case that the words you type in a mental health app are not just random chatter. They contain valuable information about your mental state, particularly concerning depression. While we're not quite at a point where your chatbot can diagnose you, this research opens up exciting possibilities for understanding mental health on a larger scale, improving digital interventions, and ultimately helping more people get the support they need, one word at a time. This research was conducted using data from Wobot users who downloaded the app between early 2021 and mid-2023. The raw data included tons of messages and survey responses, and the team spent a lot of time cleaning and preparing it, making sure the texts were actually user-generated, and importantly, primarily in English. The app used its own custom reflection questionnaire, or RQ, which had items about symptoms, abilities, and quality of life. Since this wasn't a standard, validated test, the researchers did some clever work. They used data from a previous study where users completed both the Wobot RQ and a well-known depression scale. The PHQ-8, they trained the model to convert the RQ scores into estimated PHQ-8 scores, giving them a more interpretable measure of depression severity for their consumer data. This estimated score is what they call depression score throughout the study. For their language analysis, they took all the messages a user sent in their first week and ran them through the LIWC system. They also added in some specific psychological distance features, which look at the use of different personal pronouns and time-focused words. For the more advanced part, they used the QWN 3-8B embedding model to generate those contextual embeddings from each user's weekly messages, creating a whole conversation format for the model to process. When it came to analyzing the data, they split it into training and testing sets. They used the training set to build and perfect their prediction models, using a technique called XGBoost and optimizing its settings with a tool called Optuna. The test set was then used to see how well these perfected models actually performed on data they hadn't seen before. They did this for both the LIWC features and the text embeddings. One of the technical aspects they addressed was something called compression towards the mean in their predictions. This means the model's predictions tended to be closer to the average score than the actual scores. To fix this, they applied a bias correction method, essentially adjusting the predictions so they could be more accurately compared to the scores from the questionnaires, especially when looking at changes over time in different user groups. This reference relates to the PHQ-8, a widely used tool for measuring depression, which they use to help interpret their custom questionnaire data. This reference highlights BERT, a foundational technology in the field of transformers and language understanding, which paved the way for many of the advanced language models used today, including the one used in this study for generating embeddings. This reference points to the specific software and dictionary system LIWC that the researchers used to analyze word usage patterns in their data. This reference is related to the concept of psychological distance in language, which the researchers also investigated as a linguistic feature in their study. My personal take on this research is that it's incredibly promising for the future of digital mental health. The idea of passively monitoring mental well-being through the language we already use is a massive step forward. It democratizes data collection, making it more accessible and less of a chore for users. The fact that they could even get group-level insights from users who didn't fill out surveys is a game-changer for understanding how digital interventions are working at scale. However, as the researchers themselves rightly point out, we are still in the early stages. The modest performance at the individual level means we can't rely on this for clinical diagnoses just yet. It is more about spotting trends in large groups, which is still incredibly valuable for app developers and researchers trying to improve services. Future work could focus on making these models more sensitive to individual nuances. Perhaps by incorporating more data types like how users interact with the app, not just what they say, or by fine-tuning the language models even further on specialized mental health conversations. The potential to extend this to other conditions like anxiety is also a very exciting prospect. So, what do you think? Could your chats with a mental health chatbot reveal more about your well-being than you realize? Let me know your thoughts in the comments below. And if you found this breakdown helpful, please give this video a like and subscribe to RUBIN'S Mind Lab for more fascinating dives into the world of psychology and science. Thanks for watching, and I'll see you in the next one.